morning, friends. It gives me immense pleasure to be here for my favorite course, Flight Mechanics. This course is related to the aeronautical students of 4th semester from Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad, India. Today I am going to discuss about effect of wind direction in aircraft performance. We have seen the aircraft climbing in the previous class, different climb angle, descent angle, range during climb, range during descent. These all things we have covered. In that I have little discussed the factors affecting the climb and the descent, and the direction of the air is very important in that case. So the direction may be the headwind, the tailwind or side wind, anywhere. Air can go in any direction. But what will be the effect on the aircraft? That I am going to discuss and hope this will be very useful for all the learners. So here, as you know, I am Dr. Yagya Dutta Dwivedhi, professor from Institute of Aeronautical Engineering, Hyderabad, India, belongs to the Department of Aeronautical Engineering, IARE, Hyderabad. My today's topics are covered is effect of wind in aircraft performance, types of wind, headwind, tailwind, ground velocity, range equation with ground velocity, effect of head and tailwind in fuel consumption, then effect of head and tailwind for jet aircraft. These I am going to discuss in today's class. So, effect of wind. During flight, two kinds of wind encountered by any aircraft. One is the headwind, another is the tailwind. So, what is the meaning of headwind? I will just discuss. So, aircraft is moving in this direction, and if the wind is also in the same direction opposite to this aircraft motion, this is called headwind. Now, if I see that aircraft is moving in this direction, but your wind, this is the wind direction. This is the wind. This is called tailwind. Tailwind. This direction of the aircrafts are very important. In which direction your aircraft is moving, it is very much essential to understand. So we have the headwind and the tailwind. Due to these winds, the relative velocity will be different in each case. When aircraft encounters head or the tailwind, then the velocity of the aircraft relative to the ground, that is called Vg. So understand that here one new term has come, that is velocity with respect to the ground. Vg is different from the velocity of the aircraft relative to the free stream velocity, that is V infinity. So now the direction of the aircraft matters the ground velocity. It should be kept in mind that in aerodynamics of the aircraft depends upon the free stream velocity, not on the Vg. So if you talk about aerodynamics, we have not considered about Vg. We are always considering the free stream velocity, that is the V infinity, not the Vg. So Vg is the speed of the aircraft with respect to the ground, and this matters on the wind direction. In which direction if the wind is moving, Vg will vary. So now we will discuss about the ground velocity. What is the ground velocity? The relationship between Vg, that is the ground velocity, and the V infinity is given in this figure. If you see here in this figure number 1 and the figure number 2, you have very much different, that is velocity of the headwind. This is the V infinity is the velocity of the aircraft, and the wind is coming from this direction. So the Vg, if it is headwind, Vg will be V infinity minus VHW. Means the Vg will be reduced. If it is headwind, this is the case of headwind, and this is the case of tailwind. So in the headwind condition, the ground velocity Vg will be V infinity, the velocity of the aircraft minus velocity of the wind, which is headwind. So Vg is equal to V infinity minus VHW. For this case, for the tailwind, wind is moving from behind like this. Aircraft is also moving in the same direction. So net velocity will be, that is called the ground velocity. This Vg will be V infinity plus VTW, tailwind. So if your aircraft is moving forward and the velocity is from behind, the total velocity will be velocity of the aircraft plus velocity of the tail, or the velocity of the wind which is coming from behind. But the same thing, which aircraft is moving in this direction and the wind is in this direction, the ground velocity will be difference of both. Means the aircraft velocity minus the headwind velocity. So if aircraft is in headwind, the ground velocity will be less, and if it is the tailwind, the ground velocity will be more. For the headwind, Vg is equal to V infinity minus VHW. HW is a headwind, HW is a headwind, TW is tailwind. Okay, so now Vg is equal to V infinity minus VHW, and Vg is equal to V infinity plus VTW. So this is the equation for the ground velocity for headwind and the tailwind. Since the endurance of the aircraft depends on the aircraft relative velocity V infinity, so endurance is dependent upon this V infinity. Okay, so it is irrelevant to consider the distance covered over the ground for the calculated as the maximum endurance. But the range is depend on the types of wind. So if it is the endurance, V infinity is only required, but for the range, Vg is required, because we want to see how much distance it is covering. But the range is depend on the types of wind, that is head or the tail, encountered by the aircraft during the flight. For example, the relative wind of the aircraft is 50 kilometers per hour. Let's headwind is 50 kilometers per hour. So Vg will be 50 minus 50 is equal to 0. It means your aircraft is hovering and the range is 0. So your range will be 0. So this you have to understand, that range will be 0 if relative velocity and the headwind are same for the range. But endurance will not affect. It is depend upon the 50 only. Range equation, we have to now see that with above discussion, range is depend on the ground speed Vg. So ground speeds needs to be considered for the distance traveled over the ground just before takeoff and the landing. For distance covered S, we have Vg is equal to ds by dt, or ds is equal to Vg into dt. So this range is equal to Vg by Ct into L by D log W O by Wi initially, and this is the total. So this is the range equation. We have to use Vg by Ct. Vg is a ground velocity, L by D is a lift by drag ratio, Ct is a fuel consumption of the aircraft. So now fuel consumption. So above equation tells that range is depend on the Vg. Weight of the fuel consumption percent distance covered over the ground is equal to pound of fuel consumed per mile, that is SFC into horsepower divided by eta of propeller into Vg. This fuel consumption, it is called the fuel consumption, which also corresponds to HPR by Vg. Here HPR by Vg is a minimum. Now let us discuss with help of the graph and give a next, which is given in the next slide. So here is depend upon the HPR by Vg, means fuel consumption is inversely proportional to the Vg. So here we can see that different plots are here. Let us now draw a tangent from origin here, this point, HPR curve here, this is the power curve, this red color, this is shown here. This line intersects at the point 1 and the 2. Point 1 corresponds to the airspeed at which range is maximum without considering the wind. So at this point 1, it is considered the maximum range velocity correspondence to the airspeed at which the range is maximum without considering the wind effect, and point 2 here corresponds to the airspeed at which the range is maximum with the consideration of headwind effects. So for the headwind you have to fly in this. Now what will happen with tailwind as given in the next slide. So if this is the headwind, but if you want in the tailwind, then what will happen? So power for the headwind, this much power is required, and for the no wind, this much power is required. So to have the headwind, you need more power. Best range, that is V infinity without headwind. Best range, V infinity with no wind. With headwind, with no wind. Now, the values of airspeed for maximum range with tailwind effects can be shown by the point here 3. This is the point 3. Point 3 is left intersection of the tangent and the curve for jet propeller aircraft. The pound of fuel consumed per mile covered over the ground, 1 pound is depend upon the Vg, and here the Vg is here. So that we have to take care of. So here if you see best range speed V infinity with no wind, this is the case. Another case, if you see this is the tailwind, so it will go to the minus here. This is the minus side. So this will be intersecting here. Best range speed with tailwind. So if you want tailwind, there you have the less, here you have the more. This is the fuel consumption. Here is more, and here you have the less fuel consumption. So very interesting things are here. Effect of head and tailwind for jet aircraft. So pound of fuel consumed per mile is equal to T into delta FCR divided by Vg. Here if you see minimum amount of fuel consumed per mile, which corresponds to the maximum range, is obtained with TR by Vg. So here if you see TR by Vg minimum. So if this TR by Vg, this is the term which is minimum, then fuel consumption will be minimum. Slope of this tangents line are the minimum value of TR by Vg. So at 1 it is for no wind, at 2 it is a headwind, and this point 3 is tailwind. So accordingly, just we have to, so here point TR by VG 0.2 and the 0.3 corresponds to the value of V infinity for best range for a headwind and the tailwind. So if you are flying in this speed or you are flying in this speed, this is the best range for headwind and this is the best range for tailwind. Accordingly, we have to work on. So now we will see something here. Which of the following is favorable for an airplane operation? That is tailwind in cruise and headwind in landing. Tailwind both in cruise and the landing. Headwind both in cruise and the landing. Headwind in cruise and tailwind in landing. So if you see here, the first case, tailwind in cruise, if it is tailwind in the cruise, it is good, and headwind in the, so this answer is correct. Tailwind both in cruise and the landing, so cruise it is okay. Flying here, tailwind is okay, but for the landing we need the headwind. So this is not correct. Headwind with both in, this is also not correct. For the cruise we need the tailwind. Headwind in the cruise and the tailwind, this is not correct. So only the answer A is correct. So at times of cruise, tailwind is increases the ground speed. Then it is favorable in cruise, whereas at the time of landing, headwind is favorable as it is increases the relative wind with respect to the aircraft, and thus required velocity to sustain weight can be reduced. So case 1 is sufficient. Now I will discuss about the glide flight. So here is the diagram. Your aircraft is gliding downwards with some angle theta here. So the weight is in this direction, lift is in this direction, drag is opposite to the motion, there is no thrust. So now this is the W, so lift will counter the W cos theta, where theta is a descent angle. And this one component of this W will be opposite to here. This is the W sin theta. So this W sin theta will counter the drag and W cos theta will be countered by the lift. So these are the two equations for the glide flight. Due to the engine failure, no power is available and thus aircraft starts to glide. This phase of flight is also called the unpowered flight. The equation motion for the steady unaccelerated flight, L is equal to W cos theta, it is, and another is D is equal to, here, D is equal to W sin theta and L is equal to W cos theta. So if we divide this both, B by A, so D by L is equal to W sin theta by W cos theta. And if you see here, this W, this is the W and this is the W is cancelled. This W and this W is cancelled. So here sin theta by cos theta, this is the tan theta. Okay, or we can write this tan theta is equal to 1 by lift to drag ratio. So also if you want the maximum, how much maximum? So L by D should be maximum. So tan theta minimum, to have the minimum glide angle so that we can have more range and more endurance. So theta should be minimum. So tan theta minimum is equal to 1 by L by D maximum. So theta will be minimum when L by D will be the maximum. So this angle we should have theta minimum during glide. So in the next lecture we will see the following topic: turn performance, discussion on maneuver performance, basic maneuver of aircraft, fundamentals of turning flight, load factors and the bank angle, maximum allowable load factor for different aircrafts. These are the references: Anderson Jr., JD, Aircraft Performance and Design, International Edition, McGraw-Hill's. Next in SL by ME, Aircraft Performance, Theory and Practice, AIA Education Series, AIA 2. Any questions, you are welcome to ask. My email ID is yddwivedhi@gmail.com. You can send your email to my in this mail. You also do like and subscribe my channel. Press the bell icon. You can give comment. Please be tuned for my next lecture. Till then, goodbye and thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.